Hi, I'm Lewis Quayle, data scientist, bioinformatician, and maintainer of lewisdoesdata.com, which is my website where I blog data science tutorials and guided data analyses. The tutorial that I'm going to do today will continue on from my previous Tidyverse tips and tricks tutorial, and so we'll assume some knowledge of the steps covered there. So if you haven't seen that one yet, I'd go check it out before continuing with this tutorial. The tutorial that I'm going to do today will focus on a few staple functions from the Tidyverse and Tidytext packages that are super useful for working with and plotting categorical variables, which is one of, if not the most common tasks when undertaking exploratory data analyses. So as usual, the first thing to do is going to be to run some setup code and load our dependencies. So we're going to load the Tidyverse meta package, as well as the Tidytext package. And then I've set a custom plotting theme function here, which you don't need to worry about too much, but the code for that will be provided in the blog post if you want to make your plots with the same layout as the one that I'm using here. And then finally, we're going to set that custom plotting theme as the default plotting theme for ggplot2. So the next thing to do will be to load our data. The dataset that we're going to use for this tutorial will be the same volcano eruptions dataset from the Tidy Tuesday project that we used in the last tutorial, but this time we'll only need the volcanoes table. So let's load the volcanoes table using the URL, which points to the CSV file in the Tidy Tuesday GitHub repository, and we're going to do that using the read CSV function and save it as the volcanoes, this volcanoes object, which will then appear in the global environment. So as a quick refresher, let's just have a quick look at the volcanoes dataset that we've just loaded. So we can see we have a unique volcano identifier number, the volcano name, the primary volcano type, some information regarding the last year that the respective volcano erupted, as well as some geographical information. So we have the country, the region and the sub-region, longitude, latitude and elevation, the plate tectonic setting, the evidence for the last eruption, as well as some geological information encoded in these major rock type variables. And then finally, we have the populations living within defined distances of the respective volcano. So that's just a quick overview of the data set that we're going to be working with. In the last tutorial, we made a version of the volcanoes data within which we'd cleaned up the primary volcano type variable, and it'll be really useful for us to have done the same series of steps here. So let's clean that up really quickly and save the clean version to a new environmental variable with the same name as what we used last time. And last time we called it volcanoes clean, and then we took the volcanoes data set and we pass that to the mutate function, within which we cleaned up the primary volcano type, and we did so by saying that the primary volcano type is passed to the str remove function. And what we're going to do here is use a regular expression to remove open brackets and any character matched within those brackets at least one time, and then close brackets or question mark. And then we will use the str to title function so that we ensure that the first letter is capitalized and all the other characters within the string are lowercase. So if we run that, we now have this cleaned version of the data that we were using last time. And if we take a quick look at that, we can now see that we have this primary volcano type variable with entries where the first letter is capitalized and the remainder of the string is lowercase. So the first thing that I wanted to cover in this tips and tricks tutorial was how to lump together the minor levels of categorical variables. So the FCT lump functions from the forecast package, which is part of the core Tidyverse, are used for binning the less frequent levels in a categorical variable into a level labelled other by default. And this can be more useful than you think, as it's much more convenient than manually recoding the factor levels in instances where you want to undertake this kind of binning. So there are a few variations on the FCT lump function, but the one I'm going to demonstrate here is the FCT underscore lump underscore n function, which lumps all levels except for the n most frequent. So if we first consider the primary volcano type variable in the volcanoes clean data set that we've just created, and we say count, which you'll remember from last time, and we're going to say primary volcano type, and we're going to name that count, and then we're going to say sort equals true. And that's just to give us a preview of the ordered levels within that variable. So we can see that there are 16 levels in this categorical variable, many of which are infrequently occurring. In fact, 14 out of the 16 that we have here occur less than 100 times within the data. And it might be that we don't want to filter these levels out, but instead include only the two largest groups and a third with everything else combined. And that's where the FCT lump function might come in. So we'd say volcanoes clean, pipe that into mutate, and then we would say primary volcano type equals FCT lump n, and then we'll say primary volcano type n equals 2. And then in order to preview that in the same way that we just have, we'll simply copy this counting code here, paste that below. So if we run that now, we can see that we have the stratovolcano and the shield primary volcano types with the same counts as we did before, so 461 and 118. So if we look up, we have stratovolcano with 461 and shield with 118. But now we have this third level called other, which is everything else combined and the respective count. Now, as you'll remember from last time, we can create and act on variables on the fly using count. So a shorthand way of doing this to save us the mutate call would have been to simply have this code instead of the mutate call, and we could have that code inside the call to count. So if we run that, we get the same output, and that saves us one line of code effectively. So something worth mentioning is that it is possible to change the name of the other level, and there are variations of the function which will lump the infrequently occurring categories based on, for example, a minimum threshold, or whether they occur as at least a given proportion of the total. And you can view this information in the help files. So if you recall how to do this, we can use the help function, and we can say FCT lump, which is the parent function name, and that will bring up the help pages, and we can see that there are variations on FCT lump, and that there are a series of different arguments that we can use to control the behavior, within which there's this other level argument where you can change the name of the category which all of the levels are combined into. So that's FCT lump. Now let's look quickly how to make what I think is probably the most useful exploratory plot for categorical data. So the usual way of visualizing categorical data is using simple frequency counts for categorical variables as a bar chart. And the ggplot package can get a tiny bit confusing for new users when it comes to certain things like making bar charts. And the reason for this is that there are effectively two types of bar chart. The first one's a chart of frequency counts, and the second is where the bar represents the actual numeric values in the data. So let's give an example of the first type. So if we say volcanoes clean and we pass that into the ggplot function, and we create our aesthetic mapping, and we're going to say x equals primary volcano type, and then we're going to add the geom bar geometry in order to visualize that. And if we run that code, we'll get a plot. It's not a very nice looking plot, but we get a plot of the frequency counts for each of the primary volcano types in our dataset, which you can't read because the labels are overlapping, but we are going to address this shortly. Now in this case, the bar geom uses stat count in the background by default, so it does the frequency counting of each level in the categorical variable mapped to x, which in this case is the primary volcano type, and then plots these frequency counts on the y-axis, which is why when we created the graph in code, it only needs the aesthetic mapping for the x-axis. And you can see this if you consult the help page for geom bar, just in the same way that we've just done for the FCT lump function. So as I mentioned, the second type of bar plot is where you have numeric values associated with each level that you want to plot. And in this case, we have two options. The first is to add the y-axis mapping for the variable that you want to plot, and then change the stat used by geom bar. So let's imagine that we wanted to plot the mean population for people that live within 5 kilometers of each primary volcano type globally, for example. So we'd do that by saying volcanoes clean, and then pass that into group by, and then we'd say primary volcano type, and then we'd say summarize, and then we'll create a summary variable. In this case, we're going to call it mean pop 5km, and that's going to be created by using the mean function. And then we're going to compute the mean of the variable population within 5 kilometers. So we'll quickly run that. You can see the output. So what we've done is we've computed the mean population that live within 5 kilometers of each of the primary volcano types within the data. So then we can continue by passing this into ggplot. And in this case, when we create our aesthetic mapping, we have to say x equals the primary volcano type, and y equals, and in this case it's the variable that we created, mean pop 5km. And then we're going to add the geom bar, but if we try to run this without any further code, we can see that we get an error. Now, in order to plot the actual numeric values rather than what geom bar is trying to do and plot frequency counts, is to change the default stat from stat count, and in this case we're going to change it to identity. So this is saying plot the values associated with each level mapped to x. And when we do that, we can see that we now have the numeric values that we computed in the data frame shown in the console here, and we have those now plotted on the y-axis against this mean pop 5km variable that we created. However, the convenient tip that I wanted to share is the second option that I mentioned that you have available to you when you want to plot the numeric values associated with a variable. So that is a slight modification on this code. So I'm just going to copy paste this code. And now, rather than using geom bar stat equals identity, we can simply use geom_col, which is a convenient wrapper function, and it will give you exactly the same output. So just remember that geom_col is the same as geom bar with stat equals identity, and when you use geom_col or geom bar stat equals identity, you need a y aesthetic mapping. But if you're just using geom bar alone to plot the frequency counts computed in the background, you only need the x aesthetic mapping, similar to when you create histograms of continuous variables. So now that we know all this, we should realize that if the values associated with the levels of the categorical variable are pre-computed frequency counts, like those that we learned how to make using the count function in the previous tutorial, we now know that we can't use the out-of-the-box version of geom bar. And this is the thing that always seems to confuse people with geom bar, but instead we can use geom_col. So if we had said volcanoes clean, to give an example of this, and then we said count primary volcano type, name equals count, sort equals true. That creates our counts data frame for each primary volcano type, as we've seen a number of times before. Now, if we wanted to plot that, we could simply use the plotting code similar to that we've seen above. So we'd say pass that to ggplot, create the aesthetic mapping, x is the primary volcano type, y in this case equals count, and then we're going to say geomcol. And now we have these frequency counts that we've just seen computed, plotted against every primary volcano type. Now, another tip related to this is to do with the actual data visualization. And as the plot stands, we've mentioned this already, we can't read the x-axis labels. So we could go to the trouble of modifying the theme layer within ggplot and rotating the text, but that's definitely not the best option. Instead, we can just flip the plot around. And in order to do this, we now have two options available to us. Now, the first one is another function called coord flip. So I'm just going to copy paste the code that we've just written. And the coord is another ggplot layer. So we add it to the plot and we say coord underscore flip. Now, if we run that, it'll flip the plot round. So now the primary volcano type appears on the left and the counts appear along the bottom axis. Now, the reason that I'm careful to not say the y-axis and the x-axis is because actually primary volcano type is still mapped to the x-axis and counts are still mapped to the y-axis. So if you wanted to use things like the scale functions, you would have to for primary volcano type modify the x-axis, and for the counts you'd have to modify the y-axis, and that's something that often trips people up. The second option available to get the plot in this format is the one that I think makes more sense, which is to simply reverse the axis mapping. So in this case we could just map x to count or count to x and primary volcano type to y and keep the rest of the code the same. Now if we run that, we get exactly the same plot, and now we can see that primary volcano type still appears on the left, but now this is actually mapped to the y-axis and count is actually mapped to the x-axis. So there's no reversal there that might be confusing if you're modifying other layers of the ggplot code. I personally prefer the second method, but both of them are viable options. The coord flip method used to be the only way of doing this, which is why I mention it, and you might see it in some other tutorials, particularly older tutorials, but the second option is now preferred, as it also leaves the coord layer available for other plot transformations. So that's the quick exploratory bar chart from count summaries using geomcol and coord flip, and this is probably the most useful plot for exploratory analysis in terms of categorical variables. But there's still some improvements that we can make on this in terms of data visualization best practices, not just in terms of prettifying it. And one of those things would be to actually get our counts in order. So you can see from the plot that we've just created that despite our call to the count function sorting the data, which if we recall the output that we created previously, the counts data in that data frame that we pipe into ggplot are sorted in descending order, but we can see on the plot that the count data aren't plotted in that order. And the reason for that is that the primary volcano type is plotted in order of the underlying factor created by this categorical variable, and in this case it's been plotted in descending alphanumeric order, so V down to CA. So the further improvement that we could make is to actually reorder the primary volcano type factor in order to get the bars on the plot in the descending order of the magnitude of the frequency counts, and we can do that using the FCT reorder function. So the first option would be to take our plotting code and reorder the y-axis variable on the fly using the FCT reorder function. So we'd say FCT reorder the primary volcano type according to the counts, and then we make sure that we've created enough closed brackets, and then if we run that, we now have the y-axis in the descending order of the magnitude of the frequency counts that we created, but the variable is called the actual function call that we've used to create that. The second option is a little bit more long-winded, which goes against most of the tips and tricks that I've been showing, which reduce the number of lines of code, but I actually in some cases do advocate for being a little bit more verbose about things. So the option that I prefer is to actually say primary volcano type equals, and then we can take this FCT reorder code from here. So what we're doing is actually using the call to mutate to reorder the primary volcano type factor first before then passing it to the plotting code. And that gives us exactly the same plot, and now you can see that we don't have a function call as our label. As I mentioned before, there are many more modifications that you can use to prettify this plot, so if you want to learn more about how to use ggplot2, I wrote a series about just that on my blog a little while ago, so you can go check that out. But as far as an exploratory plot goes, this would be where I'd probably leave it, particularly if you're not going to be showing it to somebody else and you're just using it to understand your data. So while I'm on the topic of reordering the bars on a plot, one thing that I get asked how to do fairly frequently is how to reorder the bars on faceted plots. And this isn't something that's natively easy to do within just the core Tidyverse, but the Tidytext package that we loaded in at the outset contains a couple of convenient functions for doing this. So I thought I'd show off how to do that because this is another one of those things that you don't see showed how to do very often, but can actually be really useful. So the first thing that we need to do is create some plotting code to create a faceted plot. So what we're going to do is we're going to say count by country, and then we're going to say primary volcano type, and we're going to lump the primary volcano type in the way that we've seen previously into, in this case, we're actually going to create 6 levels. So we're going to say n equals 5. So that'll give us the top 5 most frequently occurring, so it's FCT lump n, strictly speaking. So it'll give us the 5 top levels and then everything else binned into the other category. And then we're going to call it name equals count, and then sort equals true. And then we're going to say group by primary volcano type, and then we're going to pass this to the slice max function, which is a function that I haven't covered before. We're actually going to use this to get the 5 most frequently occurring countries, or the top 5 countries by primary volcano type. So we're going to say order by count, and then there's an argument called with ties. We want to set that to false, and then we're just going to remove the grouping that we created using the group by function because slice max doesn't natively do that. And now we're going to create our plot. So we're going to say x equals count, y equals country, and then we're going to create a bar plot using geoncol like we've seen earlier on in the tutorial. And now we're going to create our facets. So we're going to say facet wrap, and the variable that we want to facet by is the primary volcano type. And then we're going to set the scales arguments, and we're going to say free y. And then one final thing I'm going to do so that it doesn't get confusing is just to set the y-axis labels to null. We can now see, if I zoom in, that we've created a faceted plot where we've got the top 5 countries by according to each of the the 6 categories of the primary volcano type that we've created. So the 5 most frequently occurring, and then this other level that we created. So we've done all that in order to show you how to reorder the bars within each of the facets with relative ease. And as I said, this ability comes from the Tidytext package, which is a fantastic package for text mining and analysis inside the Tidy Tools framework. And it just happens to come with this couple of functions that makes reordering within facets a doddle. So we can actually modify the code that we've just created with a relatively small number of additional lines to achieve the effect that we want. The first one is to add a mutate call, and I'm just doing this with a little bit of spacing so it's clear what I'm doing. So we're going to say country equals, and then this function reorder within, which comes from Tidytext, and we're going to say country count primary volcano type. So that's we're going to reorder the country variable by the count variable within the primary volcano type variable. And let's just run that just to show you how that now looks. I'll have to zoom in. So now you can see that we've got our bars reordered within each of these different facets, but we've got these sort of unwieldy y-axis labels. So there's an additional function that we can use in addition to the ggplot code, and again I'm just going to create a bit of space so you can see that, and that is so it's a really convenient function that means you don't have to actually modify the strings which act as the labels, and that is just scale y reordered. And now when we run this code and go to the zoomed in plot, we can see that we've achieved our goal. So we've got nice facets where each individual facet has nicely ordered bars in order of the frequency counts. We've got our top 5 most frequent volcano types, as well as this other that we've created, and we've got our countries on the y-axis and counts on the x-axis. As a closing remark, the 4cats package is really handy to know for working with categorical variables, so I highly recommend checking the vignette for that out in more detail. And Tidytext is well worth a look for anybody interested in text analysis and natural language processing. So that actually brings me to the end of this tips and tricks tutorial, but I'll be back very soon with the next part in the series, in which I'm going to take a look at some of the more intermediate level functions in the Tidyverse that you'll need for actually wrangling data. In the meantime, I hope you enjoyed the video and the tutorial. Please like and subscribe to my channel if you want to keep up to date with my latest tutorial videos, and also feel free to get in touch in the comments or via my website. Have fun with your data analyses, and I'll catch you all again soon.